Two volcanoes are erupting in Guatemala at the same time, and the agency monitoring both of them has not used the word coincidence once in any bulletin this month. We record. What follows is reported by official channels, cross-referenced against 3,000 years of human record, and delivered to you exactly as the instruments and the historians have logged it. The first is Volcán de Fuego, the volcano of fire, rising above the Guatemalan highlands 16 kilometers from the colonial city of Antigua. It has not stopped erupting since January of 2002. For more than 2 decades, it has produced strombolian explosions on a near-continuous cycle, and as of this week, the Instituto Nacional de Sismología, Vulcanología, Meteorología y Hidrología, the national monitoring authority known by its acronym INSIVUMEH, is logging between 6 and 12 explosions per hour, with ash columns reaching 4 to 5 kilometers above the vent. On the 12th of June, before dawn, a paroxysmal event lit the upper slopes of the volcano bright enough to be seen from the central highlands, a column of incandescent material rising into the dark sky over coffee plantations that have been worked at the base of this mountain for more than a century. 5 days before that, tourists on the overnight trail at the neighboring peak of Acatenango filmed a detonation from 400 meters away, close enough that the shock wave registered on their recordings before the light did. The volcano's flanks are cut by deep ravines, drainages with names the surrounding villages have used for generations: Seca, Taniluya, Ceniza, Las Lajas, Honda. These channels exist because previous eruptions carved them, and they remain the paths that future pyroclastic flows and lahars are expected to follow, directly toward communities that have settled at their mouths over the past several decades. The second volcano sits 23 kilometers to the west, inside a crater that did not exist before 1902. Santiaguito is the name given to the lava dome complex that has been growing continuously inside the wound left by Guatemala's largest historic eruption. This week, the active vent within that complex, a dome named Caliente, the hot one, has produced multiple pyroclastic flows, the latest confirmed in INSIVUMEH's special bulletin issued during the overnight hours, with collapsing material descending the southeast and west flanks and an ash column reaching 3,200 meters above sea level. Ashfall has been confirmed in the communities of Loma Linda and San Marcos Palajunoy on the southwestern drainage, where ash from this dome complex has settled, on and off, for more than a century. Incandescence has been visible from the crater rim on clear nights this week, a steady orange glow against the dark silhouette of the dome, monitored continuously by INSIVUMEH's seismic stations and the Washington Volcanic Ash Advisory Center's satellite passes. Two volcanoes, the same subduction zone, the same week, both producing pyroclastic activity, both under continuous instrumental surveillance, both already responsible, in their separate histories, for some of the deadliest volcanic events the Western Hemisphere has on record. Fuego's 2018 paroxysm killed more than 190 confirmed dead, with hundreds more reported missing, and, by some local and aid organization estimates, a true toll that may run far higher because the pyroclastic deposits that buried the villages of El Rodeo and San Miguel Los Lotes in the Escuintla department were too hot to approach for days and too deep to fully clear afterward. Santiaguito's parent eruption in 1902, the explosion of Santa Maria, is ranked among the 5 largest volcanic events of the past 2 centuries, anywhere on Earth, ejecting an estimated 8 cubic kilometers of magma over 2 days in October of that year and sending ash that was documented falling as far away as Mexico and the southern United States. Both mountains sit along the Central America volcanic arc, the chain produced where the Cocos Plate is forced beneath the Caribbean Plate, a subduction system that runs the length of Guatemala's Pacific-facing highlands and produces, on a geological clock that does not pause for news cycles, some of the most consistently active volcanism anywhere on the planet. From the rooftop terraces of Antigua, 16 kilometers from Fuego's summit, residents can watch the volcano smoke on any clear morning without climbing anything at all. From the city of Quetzaltenango, the regional capital nearest Santiaguito, the dome complex is visible glowing red against the night sky when cloud cover lifts. These are not remote, theoretical hazards. They are visible, daily, lived with features of the landscape for the communities settled around them, which is exactly why the agencies tracking both systems issue bulletins on a schedule measured in hours, not weeks. Tonight we are going to walk through what the instruments are recording at both volcanoes, in full technical detail, with the agencies that are tracking them and what their data means. We will name the monitoring networks involved, the specific readings each has logged this week, and what those readings mean for the people living in the shadow of both mountains. Then we are going to do something the morning news cycle will not do. We are going to go back through the documented historical record of this same volcanic chain, including a sequence of earthquakes in 1902 that the people living here at the time correctly read as a warning, months before anyone understood why, and a string of 20th century eruptions that followed patterns we are going to lay out in careful, verifiable detail. And then we are going to go further back than written history easily reaches, into the oral and textual record of cultures who watched mountains like these long before any seismometer existed, who gave this kind of mountain a name and a character, and who left behind a description of what a fire mountain does that is, in places, difficult to read as anything other than precise. This report is not going to claim that ancient peoples predicted modern volcanology. It is going to show what they wrote down in their own languages, preserved through their own methods of transmission, material worth sitting with for how closely it tracks what is happening in Guatemala this week. There is a detail buried in the agency data on Fuego's current eruptive phase that has not been widely reported, a number that connects this week's activity to a specific historical interval most coverage has missed entirely. We will reach that number before this report closes. This is Last Light Bureau. We are not a news channel chasing the next clip, and we are not a doomsday channel manufacturing dread where none is warranted. What we do here is slower than that. We take a real, verified event, tracked by real agencies, and we hold it up against the full weight of the historical and ancient record because we believe that record has something to tell us that the daily news cycle does not have time to say. Tonight's report draws on INSIVUMEH bulletins, the Smithsonian Institution's Global Volcanism Program, the Washington Volcanic Ash Advisory Center, and a documented textual record stretching from highland Guatemala to the Roman Bay of Naples to the hymns of the Rig Veda. Where that record exists, we will name it. Where it does not, we will say so plainly. The data is on the record. The interpretation is yours. If you are watching tonight, wherever you are, tell us in the comments where you're watching from. We file a report like this every night on whatever the agencies have logged that day, and we go through it at full depth rather than skimming the surface for a headline. The file never closes early, and it never closes light. The full record starts now. Volcán de Fuego, Guatemala, 14.47 degrees north, 90.88 degrees west. Summit elevation 3,763 meters, has been in continuous eruption since January of 2002, and the Instituto Nacional de Sismología, Vulcanología, Meteorología e Hidrología confirmed renewed explosive activity through the night of June 21st into the morning of June 22nd, 2026, Central America time, with the equivalent coordinated universal time falling 6 hours ahead. There is a number in this week's INSIVUMEH catalog data for this volcano that connects its current activity to a specific historical interval, a number most general coverage of this eruption has not mentioned. We will reach it before this section closes, and a separate ancient textual record, written in a language that predates Spanish contact with this region, will name the mountain itself before this report is finished. INSIVUMEH's most recent special bulletin, filed for the period running from June 21st into June 22nd, logs explosions occurring at a rate of up to 12 per hour, each producing plumes that have risen as high as 1,037 meters above the vent on the more energetic pulses logged earlier this week, with the higher estimate from the 12th of June reaching 4,500 meters above the vent during the paroxysmal event that began before sunrise that day. The Volcanic Ash Advisory Center in Washington, the body responsible for issuing aviation warnings across this region under the international framework coordinated through the International Civil Aviation Organization, has issued a string of advisories through the same window, the most recent confirming an ash cloud estimated at 14,000 feet, or roughly 4,300 meters above sea level, drifting northwest at a rate of 15 to 20 knots, derived from a combination of GOES, 1.9 satellite imagery, ground-based webcam confirmation, and numerical weather prediction models. 3 independent data streams are converging on the same picture. The seismic network INSIVUMEH operates around Fuego's summit, a set of instruments capable of distinguishing between the low-frequency rumble of degassing, the sharper signature of an explosive pulse, and the distinct seismic character of a pyroclastic flow as it begins moving down a drainage, is recording explosion signals consistent with sustained strombolian activity, the kind of eruptive style in which gas bubbles rise through a column of low-viscosity basaltic magma and burst at the surface, throwing incandescent fragments into the air in discrete, repeated bursts rather than one sustained explosive event. Satellite thermal data, gathered by infrared sensors aboard weather satellites that can detect heat signatures invisible to the human eye, is confirming weekly to moderately elevated surface temperatures at the summit, consistent with an open, actively degassing vent. And ground-based visual observation, maintained from observatory posts on the slopes of neighboring Acatenango and from communities in Panimaché and Sangre de Cristo, is confirming what the instruments suggest. Incandescent material visible at night, audible booms and rumbling reported as far as several kilometers from the summit. And on multiple nights this week, incandescent block avalanches, masses of hot rock breaking loose from the upper cone and tumbling down the established drainages. Those drainages matter, and we want to be precise about why. The Seca drainage to the west, the Taniluya and Ceniza drainages to the southwest, Las Lajas to the southeast, and Honda to the east are not incidental geographic features. They are the channels that previous lava flows, pyroclastic flows, and lahars have carved into Fuego's flanks over centuries of repeated activity, and they function exactly the way a drainage channel functions for water. They are the path of least resistance for anything moving down the mountain at speed. INSIVUMEH's bulletins this week confirm incandescent block avalanches descending multiple of these channels simultaneously, sometimes reaching vegetated areas at the base of the cone. Ashfall during the same window has been confirmed in Panimaché 1 and 2, Morelia, Santa Sofia, and El Porvenir, communities sitting along the southwest and west drainages. Consistent with the prevailing wind direction, the Washington VAC has logged moving material northwest and west through this period. It is worth naming explicitly what makes this particular eruptive phase different from an ordinary week at Fuego, because Fuego erupting is not, by itself, unusual. Smithsonian's Global Volcanism Program classifies the volcano's activity since January 2002 as a single continuous eruption, now running more than 2 decades, one of the longest sustained eruptive sequences anywhere on the agency's global ledger. Most days, that means 6 to 12 explosions per hour, ash to a few kilometers, incandescent block avalanches confined to upper slope drainages, and tourists on Acatenango filming a remarkable but statistically survivable nightly show. What makes this week notable inside that 2-decade baseline is the paroxysmal event of June 12th, which produced plume heights nearly 4.5 times the routine daily maximum, and the persistence, through the week that followed, of elevated explosion rates that have not fully relaxed back toward the lower end of the typical range. INSIVUMEH's own bulletins, read in sequence across the past 10 days, show a pattern of sustained elevated activity rather than a single spike followed by quiet. That sustained elevation is the specific signal the agency is tracking, and it is the reason this week's bulletins carry a different tone than the routine daily notices Fuego has generated for the past 24 years. There is a number buried inside this week's INSIVUMEH data that has not been widely reported in general coverage of the eruption, and we are going to name it now rather than save it for later because it matters to understanding the scale correctly. Fuego's historical eruption catalog, maintained jointly by INSIVUMEH and the Smithsonian Global Volcanism Program, documents at least 55 confirmed eruptive episodes since 1524, with the volcano active during 83 of the past 502 years on record, a base rate of roughly 1 year in 6. Since 1900 specifically, the volcano has been in eruption during 46 of the past 127 years, a rate of nearly 1 year in 2.8. The current continuous phase, beginning in January 2002, has now run for more than 24 consecutive years, making it not merely another entry on that historical list, but the single longest sustained eruptive interval Fuego has produced in the entire documented record. That number, 24 years and counting, is the detail this report promised in its opening minutes. We will return to what that duration means when we reach the historical section. Now to the second volcano. 23 kilometers to the west of Fuego, the Santa Maria volcanic complex sits at 14.76 degrees north, 91.55 degrees west, with the active Santiaguito dome complex rising within the crater left by the catastrophic 1902 eruption. INSIVUMEH's bulletins for the period spanning June 15th through June 21st confirm continuing eruption at Santa Maria, with explosions producing plumes rising to a maximum of 3,200 meters above sea level, rockfalls descending multiple flanks of the active Caliente dome, and, critically, confirmed pyroclastic flow activity, specifically lava flow front collapse pyroclastic flows, in which advancing lava at the dome's edge becomes structurally unstable and collapses, generating a fast-moving current of hot gas, ash, and rock fragments that travels downslope independent of the slower-moving lava itself. The Washington VAC's most recent advisory for Santa Maria, filed at 10:40 Coordinated Universal Time on June 21st, confirms a possible volcanic ash emission moving southwest at 10 knots, sourced from GOES-19 satellite data and numerical weather prediction modeling, with the note that the emission was not independently confirmed in satellite imagery due to meteorological cloud cover over the summit area, a common monitoring challenge at this site, given the dome's position inside a deep, frequently cloud-bound crater. This is an important detail about the limits of remote sensing at Santa Maria specifically. Where Fuego's open, exposed cone allows relatively unobstructed satellite and webcam monitoring. Santiaguito's dome complex sits low inside the 1,902 crater, surrounded by crater walls that frequently trap cloud and fog, meaning ground-based seismic and visual monitoring from INSIVUMEH's local observatory network carries disproportionate weight in tracking this specific volcano compared to Fuego. INSIVUMEH's special bulletin from the period of June 15th through 16th describes the most significant single event of the past week at this site in detail: explosions. With plumes reaching the 3,200-meter mark, hot rockfalls, and confirmed plume material from a pyroclastic flow, with incandescence observed from the crater of the Caliente dome and ashfall reported in Loma Linda and San Marcos Palajuno. This pattern, explosive activity accompanied by partial dome collapse generating pyroclastic flows on the order of several kilometers, is the characteristic failure mode of the Santiaguito dome complex and has been documented repeatedly across the past 2 decades of its activity. The dacitic lava that Santiaguito extrudes, nearly identical in composition to the material erupted catastrophically in 1902 according to the Smithsonian's geological assessment, is viscous enough that it does not flow easily. Instead, it accumulates at the vent, building dome structure that periodically becomes gravitationally and structurally unstable, collapses under its own weight or under renewed pressure from below, and generates the kind of pyroclastic flow INSIVUMEH has confirmed multiple times this week. We want to name, plainly, the 2 agencies whose data underwrites everything in this report, and explain what each one actually does, because the authority of tonight's briefing rests on understanding their roles precisely. INSIVUMEH is Guatemala's national authority for seismology, volcanology, meteorology, and hydrology, operating ground-based seismic stations, gas measurement instruments tracking sulfur dioxide flux as an indicator of magma movement, thermal imaging from both ground stations and satellite passes, and direct visual observation posts staffed in the field. It is the frontline monitoring body for both of tonight's volcanoes and the source of the special bulletins this report has quoted throughout. The Washington Volcanic Ash Advisory Center, operated under the United States National Oceanic and Atmospheric Administration's Satellite and Information Services arm, exists specifically to track and forecast the movement of volcanic ash clouds for aviation safety purposes across its assigned region of responsibility, which includes Central America, it does not replace INSIVUMEH's ground truth monitoring of the volcanoes themselves. It provides an independent, satellite and model-based cross-check on what material is actually airborne and where it is going, which is precisely why this report has been able to corroborate INSIVUMEH's ground observations against an entirely separate data stream throughout. There is a question worth asking directly, and it is the question this report is going to answer by its end. Is it meaningful that two of Guatemala's most historically destructive volcanic systems are producing confirmed pyroclastic activity in the same calendar week? Or is this simply what background volcanic activity in this country looks like in any given month? The honest answer, the one the agencies themselves would give if asked plainly, is more nuanced than either a dismissal or an alarm. Guatemala sits on a section of the Central America volcanic arc with 3 currently erupting volcanoes tracked in the Smithsonian's global catalog: Fuego, Santiaguito, and Pacaya, which has been active since 1961. Multiple simultaneous eruptions in this country are, in the loosest statistical sense, not abnormal. They are close to the baseline condition of this particular stretch of subduction zone. What is specific to this week, and what the agency's own bulletins single out for elevated attention, is the persistence of above baseline activity at Fuego following the June 12th paroxysm, and the confirmed pyroclastic flow activity at Santiaguito occurring within days of that escalation at its neighboring system 23 kilometers away, on the same arc, fed by the same subducting plate. One additional verified figure belongs here, because it is the kind of detail that general news coverage of this eruption has tended to omit. INSIVUMEH's gas measurement program at Fuego tracks sulfur dioxide flux as a leading indicator of fresh magma ascent, and the agency's reporting through the current elevated period has noted output consistent with continued magma supply from depth, rather than a system that is winding down toward quiescence. This is a meaningfully different signal than a volcano producing its last gasps of an exhausted eruptive pulse. It is the signature of a system actively being resupplied, which is part of why INSIVUMEH's bulletins have continued at special report frequency through this entire window, rather than tapering back toward routine daily notices. It is worth walking through the monitoring infrastructure itself in more detail, because the density and sophistication of the network watching these 2 volcanoes is part of what gives tonight's data its weight. INSIVUMEH maintains a multi-instrument array specifically built around Fuego, seismic stations ringed around the cone that detect explosion signals, the continuous low-frequency tremor that often precedes stronger pulses, and rockfall signatures in the major drainages, gas measurement instruments that sample sulfur dioxide flux, treated across volcanology as a leading indicator of changes in the magma column beneath the vent, since rising gas output frequently signals fresh magma rising toward the surface. Thermal imaging from both ground-based stations on Acatenango slopes and periodic satellite passes used to track hotspots, lava flow advance where it occurs, and the presence of pyroclastic material in the upper drainages, and direct visual observation posts staffed in Panimaché and Sangre de Cristo, providing real-time line-of-sight confirmation of what the instruments are recording. During stronger pulses, INSIVUMEH has also used drone observation to document crater morphology and confirm precisely where material is being ejected from the vent, a capability that has become standard practice at this volcano specifically because of how frequently it produces activity worth documenting at close range. At Santiaguito, the monitoring picture is necessarily different because the hazard itself behaves differently. Where Fuego's summit is an open, exposed cone visible from wide angles, the active Caliente dome sits low inside the 1,902 crater, a topographic bowl that traps cloud cover on a majority of days and limits both satellite confirmation and distant visual observation. INSIVUMEH compensates with a denser reliance on local seismic stations capable of detecting the specific signature of dome collapse, the seismic energy released when a section of the unstable dome face gives way and begins moving downslope as a pyroclastic flow, along with ground-based visual monitoring from observation posts positioned with direct sightlines into the crater when weather permits. The seismic station designation, STG-3, referenced in INSIVUMEH's own historical reporting on this site, has recorded everything from weak explosions producing airplane turbine-like sounds to the sharper signature of block avalanches descending the dome's southern, eastern, and southeastern flanks, and it remains one of the primary instruments translating what is happening inside that cloud-obscured crater into a record outside observers can actually read. Secondary effects at both sites deserve specific attention because they are where the practical hazard to people living nearby actually concentrates. At Fuego, INSIVUMEH's bulletins through this week confirm not only ash fall in the downwind communities already named, but ongoing recommendations to avoid the ravines during periods of rainfall because Guatemala's wet season generates exactly the conditions under which loose volcanic material accumulated in the upper drainages can mobilize into lahars, fast-moving slurries of water, ash, and rock debris capable of traveling considerable distances downstream with little warning. INSIVUMEH's historical record for this volcano documents lahars carrying branches, tree trunks, and boulders ranging from 30 centimeters to 3 meters in diameter, descending the ceniza drainage during prior rainy season periods, a hazard distinct from but directly connected to the explosive activity generating the loose material in the first place. At Santiaguito, the corresponding secondary hazard is the pyroclastic flow itself, the fast-moving current of hot gas and rock fragments generated when the unstable dome face collapses, a phenomenon that travels at speeds and temperatures that make any direct exposure within its path almost universally fatal, which is precisely why INSIVUMEH's bulletins track dome collapse signals with such granularity. We also want to address, directly and without speculation, what these two volcanoes are not currently signaling. Neither INSIVUMEH nor the Smithsonian's Global Volcanism Program has issued any elevated regional alert level beyond the routine monitoring status both volcanoes carry as a baseline condition of their ongoing eruptive activity. There is no current tsunami advisory connected to either system, no confirmed indication of a magnitude shift toward a significantly larger eruptive style at either site, and no agency statement suggesting an imminent escalation beyond what the past week's bulletins have already documented. We are naming this plainly because precision matters more than drama in this report. The data shows sustained, elevated, materially hazardous activity at two historically lethal volcanic systems in the same country during the same week. It does not show, as of the moment this report was filed, any confirmed indication that either system is approaching an eruption of the scale that produced the 2018 Fuego disaster or the 1902 Santa Maria eruption. What it does show, and what makes tonight's report worth filing in this much depth, is a real, agency-confirmed coincidence of timing between two volcanic systems with a documented history of producing exactly the kind of escalation that turns sustained baseline activity into catastrophe with very little additional warning. That distinction between sustained hazardous activity and an imminent catastrophic escalation is one we are going to hold on to carefully through the rest of this report, because it is the same distinction the historical record forces us to confront when we look at what happened here in 1902, and it is the same distinction the ancient textual record, when we reach it, describes with a precision that is worth taking seriously on its own terms. There is a second number worth placing on the record before we leave the live data and move into history. Santiaguito's dome complex, as INSIVUMEH and the Smithsonian's geological assessments both confirm, has been growing continuously inside the 1902 crater since 1922, a span of 104 years of near uninterrupted dome growth, punctuated repeatedly by exactly the kind of partial collapse and pyroclastic flow activity confirmed again this week. That number, 104 years, sitting alongside Fuego's 24 years of continuous eruption, describes two volcanic systems that have each been actively building toward their next major structural failure for longer than most living residents of the surrounding communities have been alive. Keep both of those numbers in mind. We will return to them directly when we reach the ancient record, because both numbers turn out to matter to a specific textual detail neither agency bulletin was written to address. We turn now to the historical record, because the instruments INSIVUMEH operates today are a recent addition to a much longer human relationship with these two mountains, and the documented history of this exact stretch of the Guatemalan highlands gives this week's data a depth that the bulletins alone cannot provide. Before we leave the live data, it is worth explaining the deeper mechanical picture that connects both volcanoes to the same underlying process, because understanding this mechanism is what allows the historical and ancient sections of this report to mean something more than coincidence, dressed up as narrative. Both Fuego and the Santa Maria complex sit above the same subduction interface, the boundary where the Cocos Plate, part of the oceanic crust beneath the Pacific, is being forced downward and beneath the Caribbean Plate, upon which Guatemala and the rest of Central America sit. This subduction process generates the Central America volcanic arc, the chain of volcanoes running the length of the region's Pacific-facing highlands, of which Fuego, Santa Maria, and the third currently active volcano, Pacaya, are three closely spaced members. As the Cocos Plate descends beneath the Caribbean Plate, friction and pressure generate heat, and the descending oceanic crust carries with it water locked into its mineral structure. At sufficient depth and temperature, that water is released into the overlying mantle wedge, lowering the melting point of the surrounding rock and triggering the generation of magma. That magma, less dense than the solid rock around it, rises buoyantly toward the surface, accumulating in chambers beneath the volcanic edifices that mark the surface expression of this entire process. Fuego and Santa Maria are, in this sense, two surface vents drawing on the same deep engine, separated by 23 kilometers of highland terrain, but connected at depth to the same subducting plate and the same broad zone of magma generation. This does not mean the two systems are mechanically linked in any direct, moment-to-moment sense, and INSIVUMEH's bulletins do not claim that a change at one volcano is causing a corresponding change at the other. What it does mean is that both volcanoes are subject to the same regional tectonic forcing, the same plate convergence rate, estimated for this section of the Cocosine Caribbean boundary at several centimeters per year, and the same long-term pattern of stress accumulation and release that governs volcanic activity across the entire arc. This is the appropriate moment to introduce a concept central to understanding both volcanoes' eruptive styles, the role of magma viscosity in determining what kind of eruption a given system produces. Fuego's magma is predominantly basaltic to basaltic andesitic in composition, relatively low in silica content, which gives it comparatively low viscosity. Low viscosity magma allows dissolved gases to escape more readily as the magma rises and pressure decreases, producing the discrete, repeated strombolian bursts that characterize Fuego's typical activity, gas escaping in pulses rather than building toward a single overwhelming release. Santiaguito's magma, by contrast, is dacitic, higher in silica content and correspondingly far more viscous. Gas does not escape easily through highly viscous magma. Instead, pressure builds within the magma itself as it approaches the surface, and the material that does erupt tends to pile up at the vent rather than flow away, building the dome structure that defines Santiaguito's entire eruptive history since 1922. When that built-up dome eventually fails, either through gravitational collapse as the structure becomes too steep and unstable to support its own weight, or through a more explosive release as trapped gas pressure exceeds the structural strength of the dome rock, the result is the kind of pyroclastic flow INSIVUMEH has confirmed repeatedly this week. The same subducting plate, the same regional tectonic engine, producing two entirely different eruptive personalities 23 kilometers apart. Simply because of differences in the chemistry of the magma each system happens to be erupting. That number will matter again before this report closes. Keep in mind that Fuego releases its stress in frequent, small increments, dozens of times per hour, while Santiaguito accumulates its stress in slow-building structural failures that may be separated by days or weeks. Two different release rhythms, the same underlying source. We want to address the question of monitoring redundancy directly, because it speaks to how much confidence this report can place in the data already presented. INSIVUMEH does not operate in isolation. Its bulletins are cross-checked, as this report has already demonstrated, against the Washington VAC's independent satellite and modeling pipeline, and both agencies' findings are folded into the Smithsonian Institution's Global Volcanism Program, which maintains the authoritative international catalog of currently erupting volcanoes worldwide, compiling weekly volcanic activity reports that synthesize national agency bulletins from dozens of countries into a single standardized record. The most recent Smithsonian Weekly Report covering the period through June 17th lists 22 volcanoes with confirmed activity that week, with Fuego and Santa Maria both appearing on that list, situating this week's Guatemalan activity within a broader global context of background volcanism that, on any given week, typically includes somewhere between 20 and 50 actively erupting systems worldwide. This is the appropriate context for understanding tonight's report correctly. The global background rate of volcanic activity is not low, and two volcanoes erupting in the same country in the same week is not, on its own, a statistically extraordinary event. What elevates tonight's report beyond a routine activity update is the specific historical weight carried by these two particular volcanoes, a weight we are now going to examine in full. There is a detail from INSIVUMEH's own multi-decade reporting on Fuego worth holding onto as we make this transition. The agency's records describe a recommendation, repeated across years of bulletins, to avoid being in or near the ravines during periods of rainfall, a warning grounded entirely in instrumented observation of how loose volcanic material mobilizes during Guatemala's wet season. That warning, mundane and procedural as it reads in an agency bulletin, describes the exact same hazard that the documented historical record of this region addresses in far more dramatic terms nearly a century and a quarter ago, when the volcano next door produced the largest eruption this part of the world has on record, preceded by a sequence of warning signs that the people living here at the time understood with a clarity that, in hindsight, the agencies monitoring this region today would recognize as remarkably sound seismological instinct, even without a single modern instrument to confirm it. The full instrumental record for this week is now on the table. Explosion rates, plume heights, satellite confirmation, monitoring infrastructure, the subduction mechanics underlying both volcanoes, and the agencies whose names and methods now stand behind everything in this report. We turn now to what the historical record shows happened the last time this same volcanic complex produced an eruption at truly catastrophic scale, because the documented sequence of events in the months before that eruption is going to matter directly to how we read the live data we have just walked through. It is worth spending additional time on what INSIVUMEH's own classification system tells us, because the agency does not treat all volcanic activity the same way, and understanding its alert framework clarifies exactly where this week's data sits within that framework. Guatemala's volcanic alert system, as INSIVUMEH applies it across the country's 37 cataloged volcanoes, distinguishes between routine, continuing activity at chronically active systems like Fuego and Santiaguito, and the kind of anomalous escalation that would warrant a formal alert level change. As of this report's filing, INSIVUMEH's bulletins for both volcanoes describe activity within the established range of each system's ongoing eruptive behavior, intensified relative to recent baseline, but not yet classified by the agency as an escalation requiring a change in public alert status. We want to be precise about this distinction because it is easy, in a report covering two simultaneously active volcanoes with histories as severe as these, to blur the line between heightened activity and imminent catastrophe. The agencies have not blurred that line, and neither will this report. That said, the specific character of the heightened activity deserves a closer look, because the details matter to understanding the genuine risk picture. At Fuego, the paroxysmal event of June 12th, the one that lit the upper slopes bright enough to be visible from the central highlands before sunrise, falls into a recognized category of activity at this volcano, a larger, more intense pulse within the otherwise continuous strombolian eruption, distinct from the routine 6 to 12 per hour explosion rhythm, but well below the scale of a true paroxysm, capable of generating the kind of sustained pyroclastic flows that produced the 2018 disaster. INSIVUMEH's bulletins describe these intermediate-scale events as occurring periodically, several times per month, within the volcano's two-decade continuous eruption, and the agency's monitoring posture treats them as expected variability within an already active system, rather than as standalone emergencies. What distinguishes this particular event from routine intermediate pulses is not its individual scale, which sits within the documented range, but its position at the front of a week-long period of sustained elevated explosion rates that, as we have already noted, have not fully subsided. At Santiaguito, The corresponding nuance involves the specific mechanics of dome collapse. Not every partial collapse of the Caliente dome generates a pyroclastic flow large enough to be specifically flagged in an INSIVUMEH special bulletin. Many smaller collapses produce block avalanches that remain confined to the immediate vicinity of the dome and do not warrant the elevated reporting language used this week. The fact that INSIVUMEH issued special bulletins rather than routine daily updates for the dome collapse events confirmed between June 9th and June 21st indicates that these specific collapses exceeded the threshold the agency uses internally to distinguish routine activity from events warranting heightened public communication. That threshold is not arbitrary. It reflects the agency's assessment based on instrumented seismic signal strength and the observed runout distance of the resulting pyroclastic material of genuine hazard significance. There is a retention point worth planting here because it threads directly into both the historical and ancient sections still ahead. Both volcanoes, despite their different eruptive styles, share one structural commonality. Each produces its most dangerous events not through a single, instantaneously recognizable signal, but through an accumulation of smaller, individually survivable events that occasionally, without dramatic individual warning, cross a threshold into something categorically more severe. Fuego's 2018 disaster did not begin as an unusually severe explosion. INSIVUMEH's own retrospective analysis describes it beginning as activity consistent with the volcano's established pattern before escalating, within hours, into sustained pyroclastic flows that reached populated areas with little additional warning beyond what the agency had already issued as routine guidance. Santiaguito's dome collapse mechanism is, by its physical nature, similarly threshold-dependent. The dome grows incrementally, collapse by collapse, until a particular failure exceeds the others not because it announced itself differently in advance, but because the accumulated structural state of the dome happened to cross a critical point at that specific moment. We are going to return to this exact dynamic, an accumulation that crosses an unannounced threshold. When we reach the ancient record, because it turns out to be one of the more precisely described phenomena in the textual material we are about to examine. There is a name for this kind of threshold crossing event in the volcanological literature, a critical state transition, and it is worth keeping that specific phrase in mind because the ancient material ahead returns to the same underlying idea using an entirely different vocabulary, drawn from a worldview that had no access to plate tectonics but had centuries of direct, repeated observation of exactly this kind of mountain. Let us also address, with full transparency, the limits of what this report can establish, because intellectual honesty about the limits of forecasting is part of what separates a credible briefing from a sensationalized one. Volcanology, even with the dense, multi-instrument monitoring networks INSIVUMEH operates at both of these sites, cannot currently predict the exact timing or final scale of either volcano's next major escalation with a kind of precision a viewer might reasonably want. What the agencies can do, and what they are doing right now, is exactly what this report has described, tracking explosion rates, gas flux, thermal signatures, and ground deformation in as close to real time as the available instrumentation allows, and issuing escalating levels of public communication, special bulletins rather than routine updates, when the data crosses internally established thresholds of concern. That is the unglamorous reality of volcanic monitoring at both of tonight's sites, worth stating plainly, rather than allowing the drama of the historical and ancient material still ahead to imply a false precision the live data does not actually support. We want to close this section of the briefing with one more piece of agency-sourced context, because it bears directly on how seriously the historical parallel we are about to examine should be taken. INSIVUMEH's institutional memory of this exact volcanic complex extends back, in documented form, to the years immediately following the 1902 Santa Maria eruption, when the predecessor monitoring bodies that eventually became today's INSIVUMEH began systematically tracking seismic activity across Guatemala's western highlands specifically, because of what had just happened. In other words, the agency monitoring Fuego and Santiaguito this week exists, in its modern institutional form, partly because of the catastrophe we are about to describe in the historical section. The instruments tracking this week's pyroclastic flows are the direct descendants, in an unbroken institutional lineage, of the monitoring effort that began in the aftermath of the very eruption, whose precursor sequence we are now going to walk through in full detail. That number, 24 years and 104 years, both trace back, in a sense, to the same originating catastrophe. Fuego's modern continuous phase began in 2002, but the volcano's broader documented history of frequent eruption long predates that, stretching back through the 1974 eruption that remains its largest of the 20th century, and further back still to the earliest Spanish-era records beginning in 1524. Santiaguito's 104 years of growth began directly inside the crater carved by the 1902 Santa Maria explosion, meaning the dome now collapsing in pyroclastic flows this week is, quite literally, still growing inside the scar left by Guatemala's worst documented volcanic disaster, a scar that opened 124 years ago and has never stopped producing new material since. This is the moment to make the turn the rest of tonight's report has been building toward. The live data is now on the table in full, from 2 independent agencies, covering both volcanoes, current activity, monitoring infrastructure, alert status, and the underlying tectonic mechanism connecting them. We have planted a number, 24 years and 104 years, that we are going to return to directly. Now we go back to 1902 itself, to the documented sequence of earthquakes that preceded Santa Maria's explosion, and to what the people of this region understood about what was coming months before they had any instrument to confirm it. Before making that turn fully, there is one more layer of technical context worth laying out, because it concerns a measurement that connects directly to both volcanoes' current behavior and to a number this report has not yet placed on the record: the rate of magma, supply feeding both systems, and what changes in that rate can and cannot tell observers in real time. Volcanologists infer magma supply rate primarily through 3 converging lines of evidence: ground deformation, measured through GPS networks, and, where available, satellite radar interferometry that can detect millimeter-scale swelling or subsidence of a volcano's flanks as magma accumulates or drains beneath the surface. Gas emission rate, particularly sulfur dioxide flux, which tends to rise when fresh, gas-rich magma is ascending from depth, and seismic energy release, the cumulative signature of rock fracturing as magma forces its way through the crust toward the surface. At Fuego, INSIVUMEH's continuous seismic monitoring has documented a pattern, consistent across the volcano's 24-year eruptive phase, in which periods of elevated explosion frequency, like the one confirmed this week, generally correspond to episodes of increased magma supply from depth, manifesting at the surface as the more frequent, higher Strombolian bursts the agency's bulletins have logged. This is a well-established pattern at this specific volcano, documented across multiple academic studies of its eruptive behavior, and it gives volcanologists a reasonably confident, though not perfectly precise, framework for interpreting what sustained elevated activity, like this week's, actually represents: more material moving through the system, not necessarily more danger in any single moment, but a longer window during which the cumulative probability of a larger event, a true paroxysm on the scale of 2018, remains elevated relative to a quieter period. At Santiaguito, the equivalent inference is complicated by the dome structure itself. Because the dacitic magma feeding this system is so viscous, increased magma supply from depth does not necessarily translate immediately into increased surface activity the way it does at Fuego. Instead, that material can accumulate within the dome structure itself for extended periods, building internal pressure and structural instability that may not manifest as a detectable surface signal until the moment of actual collapse. This is precisely why INSIVUMEH's seismic monitoring of dome collapse signatures carries such weight at this site. It is, in practical terms, one of the only reliable real-time indicators of when accumulated internal pressure has translated into an actual structural failure, because the lead-up to that failure can remain seismically and visually quiet right up until the moment the dome face actually gives way. This asymmetry between the two volcanoes' observability, Fuego's relatively continuous, readable signal versus Santiaguito's more opaque, threshold-dependent behavior, is itself a documented feature of the broader volcanological literature on basaltic versus dacitic eruptive systems, and it is worth naming explicitly because it shapes how confidently this report can characterize the risk at each site. At Fuego, this week's elevated activity is a directly observable, well-characterized continuation of an established pattern. At Santiaguito, this week's confirmed pyroclastic flows are themselves the primary evidence of an internal process that the monitoring network can only partially observe in advance, which is a meaningfully different epistemic situation, and one worth holding plainly rather than smoothing over for narrative convenience. We want to place one additional verified figure on the record before closing this section, because it bears directly on the historical material that follows. The 1902 eruption of Santa Maria, according to the volcanological literature, synthesizing INSIVUMEH's predecessor records and subsequent academic reassessment published in the Journal of Volcanology and Geothermal Research, produced an erupted volume estimate ranging from 4.3 to as high as 48 cubic kilometers of material, with even the most conservative published figure placing it among the 10 largest historic eruptions documented anywhere in the world. The explosion crater left on the volcano's southwest flank by that eruption measured less than half a cubic kilometer in volume, a small fraction of the total material ejected, meaning the overwhelming majority of what came out of that mountain in 1902 was thrown into the atmosphere and dispersed across the region and ultimately the hemisphere, rather than remaining as visible debris near the vent. By comparison, the dacitic lava that Santiaguito has extruded into that same crater across the past 104 years totals approximately 0.7 cubic kilometers, a fraction of the original explosive output, growing slowly, dome collapse by dome collapse, exactly the kind of accumulation this report has already described. That figure, the disproportion between the violence of the original 1902 explosion and the comparatively modest, incremental volume of material Santiaguito has produced since in its place, is the precise reason volcanologists do not consider the dome's century of growth a guarantee of anything resembling safety. A system capable of producing 48 cubic kilometers of ejecta in 2 days has not, by growing a dome one collapse at a time for 104 years, demonstrated that it has lost that underlying capacity. It has simply been releasing pressure through a different mechanism in smaller increments for a much longer period of time. Whether that incremental release represents a genuine long-term safety valve, gradually relieving the system of the pressure that built toward 1902, or whether it represents exactly the kind of slow, multi-decade pressure accumulation that historically precedes a future large-scale event, is a question current volcanological science, including everything INSIVUMEH and the broader academic literature have published on this system, cannot definitively answer. It is, in the agency's own framing, an open question under active monitoring, not a settled one. This is where the live data, in its full technical completeness, has to stop, because the instruments can tell us what is happening now and can characterize, with reasonable confidence, the immediate hazard zones around both volcanoes. What the instruments cannot tell us is the answer to the much larger question this report has been circling since its opening minutes: whether the documented severity of this exact volcanic complex's worst historical events has anything to teach us about how to read this week's data. For that question, we have to leave the instrument record behind and turn to the documented human experience of watching this same complex behave across more than a century of written and oral testimony, beginning with the earthquakes that struck this region in the early months of 1902, months before anyone understood what those earthquakes were actually building toward. Before that turn, one final piece of regional context belongs on the record, because this report has referenced a third currently erupting Guatemalan volcano without yet explaining its relevance. Pacaya, the third member of this stretch of the Central America volcanic arc, currently listed as active in the Smithsonian's global catalog, has been erupting continuously since 1961, a separate eruptive phase from both Fuego and Santiaguito, situated south of Guatemala City rather than near Antigua or Quetzaltenango. INSIVUMEH monitors Pacaya through the same institutional framework and the same category of instrumentation described throughout this report, and the agency's most recent bulletins for that system describe ongoing, routine activity without the elevated special bulletin language applied to Fuego and Santiaguito this week. We are naming Pacaya specifically to demonstrate the agency's differential treatment in practice. INSIVUMEH does not issue elevated reporting language uniformly across every active volcano under its jurisdiction. It reserves that heightened communication specifically for systems showing activity above their own established baseline, which is precisely the category this week's bulletins place Fuego and Santiaguito into, and precisely the category Pacaya's current activity does not fall into. This distinction matters because it confirms that tonight's report is not simply describing Guatemala's normal background condition dressed up as something more significant. The agency's own bulletin language draws the same line this report has drawn. It is also worth noting the broader regional monitoring context this picture sits inside. The International Association of Volcanology and Chemistry of the Earth's Interior, the body coordinating global volcanological research and data sharing standards, has in recent reporting called for increased international cooperation on real-time monitoring across active volcanic regions worldwide. A call issued partly in response to the consistently high background rate of simultaneous volcanic activity tracked across Central America, the Pacific Ring of Fire, and other major subduction systems. Guatemala, with 3 nationally significant volcanoes under continuous watch at once, is precisely the kind of case that motivates that call for deeper coordination, since a single national agency, however capable, is tasked with maintaining real-time vigilance over multiple historically lethal systems simultaneously, using a monitoring budget and staffing level that, like most national geological surveys in the developing world, operates under real resource constraints even as the hazard itself does not pause to accommodate them. No formal new coordination plan has been announced as of this report's filing. The call for it remains, for now, exactly that, a call, while the existing national monitoring framework continues to carry the operational weight of tracking both volcanoes this report has described. With that final piece of context in place, the live data is complete. 3 active volcanoes along one stretch of subducting plate, 2 of them producing confirmed pyroclastic activity above their established baseline in the same week, monitored by an agency whose institutional lineage traces directly back to the catastrophe we are about to examine, and a third sitting quietly at routine baseline, demonstrating by contrast exactly how unusual this week's elevated activity at the other 2 sites actually is. The instruments have given us everything they can give us, and what they have given us is a precise, multi-agency, cross-verified picture of 2 historically lethal systems behaving above their normal range in the same 7-day window. We now turn to the documented historical record of what this exact volcanic complex did the last time it crossed from elevated activity into genuine catastrophe, beginning with a sequence of earthquakes in the early months of 1902 that the people living in this region understood, with a clarity history has vindicated, as the warning it turned out to be. The documented record of what happened in western Guatemala in 1902 begins not with the eruption itself, but with the ground shaking, months before anyone understood what was coming. The first earthquake in the sequence struck on January 18, 1902, affecting San Martin and the broader Pacific coastal region of Guatemala. It was the opening note in what the historical record describes as a series of damaging earthquakes that continued with increasing severity over the following 9 months. The largest single event in that sequence struck on April 18th, an earthquake severe enough to raze the towns of Quetzaltenango and San Marcos, killing approximately 1,000 people, causing major structural damage that was felt as far away as neighboring countries, with its epicenter thought, even at the time, to be located near the Santa Maria volcanic complex itself. Following that April earthquake, the historical record documents something specific and worth naming precisely: a series of local earthquakes occurring with high frequency, felt continuously in the volcano's immediate vicinity for 6 weeks straight. Not a single warning tremor, but a sustained, weeks-long seismic hum directly beneath the mountain that would, in October, produce one of the largest eruptions of the 20th century. The sequence continued. On September 23rd, another major shock struck, felt as far away as Mexico. By the time slight earthquakes were noted on October 24th, the people of this region had lived through 9 months of escalating ground motion, with the geographic focus of that motion consistently centered on the same volcanic massif. The eruption began the following day, October 25th, with the largest explosions occurring over the subsequent 48 hours, ejecting an estimated 8 cubic kilometers of magma in that window alone and producing, according to the modern academic reassessment published in the Journal of Volcanology and Geothermal Research, ashfall documented as far away as Mexico, the southern United States, Argentina, and even reaching newspaper reports as far afield as Spain, Germany, and the United Kingdom, where contemporary accounts describe the atmospheric haze the eruption produced. The volcanologist William I Rose, in his 1972 paper published in the Bulletin Volcanologique examining this exact eruption, made an observation that deserves to be quoted with the full weight it carries for tonight's report. In hindsight, the 6-month period before the October 1902 eruption was one of extremely abnormal seismicity across all of western Guatemala. That phrase, extremely abnormal seismicity, written by a professional volcanologist studying the documented historical record more than 7 decades after the fact, is not folklore. It is a peer-reviewed scientific characterization of precisely the kind of precursor sequence this report's live data section addressed when discussing how volcanic systems accumulate stress before crossing into catastrophic failure. The people of western Guatemala in 1902 had no seismometers, no satellite thermal imaging, no gas flux monitoring. What they had was 9 months of their ground shaking with escalating frequency and severity, centered on a mountain that local memory and written record alike described as having been dormant by the most conservative documented estimate for at least 500 years, and by some geological estimates for several thousand. That dormancy itself deserves a moment of attention because it connects directly to the question this report has been building toward since its opening minutes. Santa Maria was, before 1902, considered by contemporary observers to be a long-extinct, scenically beautiful mountain, described by the geologist and explorer Gustav Eisen, who studied the region before the eruption, in terms closer to admiration than concern. The volcano's awakening that year was, by every documented account, a genuine surprise to the scientific understanding of the time, precisely because the long interval of quiet had been read, reasonably enough by the standards of early 20th century geology, as evidence of safety, rather than as evidence of a system slowly accumulating pressure toward an eventual, overdue release. This is the precise historical parallel this report's live data section established earlier. We described Fuego's 24 years of continuous eruption and Santiaguito's 104 years of continuous dome growth as 2 systems that have each been actively building toward their next major structural failure for longer than most living residents of the surrounding communities have been alive. Santa Maria, in 1902, had been quiet for centuries before it produced one of the 10 largest eruptions in documented world history, preceded by 9 months of seismicity that contemporary observers correctly read as significant, even without understanding the full mechanism behind it, and that the modern professional literature now explicitly characterizes as abnormal in hindsight. The connecting thread across more than a century is not that volcanic quiet guarantees future violence in some simple, deterministic sense. It is that long intervals of reduced surface activity at a subduction zone volcano are not, on their own, reliable evidence of reduced underlying hazard, and the 1902 sequence is the clearest documented case this exact volcanic complex has to demonstrate that point. There is a second historical parallel worth drawing directly from the documented record, because it concerns the specific mechanism connecting earthquakes to eruptions at this site. The seismic swarm that preceded the 1902 explosion was not, by the modern geological understanding of subduction zone volcanism, a coincidental, unrelated sequence of tectonic earthquakes that happened to occur near a volcano that was separately preparing to erupt. The current scientific consensus, built on more than a century of subsequent study of comparable systems worldwide, treats this kind of pre-eruptive seismic swarm as a direct physical signature of magma forcing its way upward through the crust, fracturing rock as it ascends and generating exactly the kind of localized, sustained seismicity the 1902 record documents in such specific detail. In other words, the earthquakes were not a separate warning sign running parallel to the volcanic buildup. They were the volcanic buildup, expressed in the only form available to instruments and observers of that era: ground motion. This connects directly to the live data this report opened with. INSIVUMEH's current seismic monitoring of Fuego tracks exactly this kind of signal: explosion seismicity, low-frequency tremor, and the broader pattern of energy release that indicates magma movement at depth, using instruments that did not exist in 1902 but that are measuring fundamentally the same physical process the people of western Guatemala experienced, without instrumentation, as 9 months of their ground refusing to stay still. The historical record does not tell us that this week's elevated activity at Fuego and Santiaguito will resolve into anything resembling the scale of 1902. It tells us, with the authority of a documented, peer-reviewed case study from this exact volcanic complex, that sustained seismic and eruptive activity at these mountains has, at least once in the past century and a quarter, been the direct precursor to the largest eruption this region has ever produced, and that the people living closest to the mountain at the time understood, well before any scientific framework existed to explain why, that 9 months of shaking ground was not nothing. That number will matter again. 9 months of documented, escalating seismicity preceded the 1902 eruption. We are now several days into a documented, escalating period of elevated activity at 2 volcanoes along the same arc. We are not suggesting those 2 timescales are equivalent, and the agencies monitoring tonight's volcanoes have made no such claim. We are noting, plainly, that the historical record gives this week's data a specific, documented precedent for what sustained pre-eruptive activity at this exact complex has looked like before, and that the precedent is worth taking seriously precisely because it is not folklore. It is published volcanology, citing newspaper archives, government records, and contemporary scientific observation, compiled and reassessed by professional researchers more than a century after the fact. A second documented parallel, distinct from 1902 but drawn from the same volcanic chain, comes from Fuego's own 20th century record. The volcano's largest eruption since the Spanish colonial era struck in 1974, a major explosive event that followed a documented buildup of the kind that has become a recognizable pattern at this specific mountain. A period of intensifying strombolian activity, gradually increasing in frequency and scale before crossing into a larger paroxysmal phase. Smithsonian's Global Volcanism Program catalogs the 1974 eruption alongside the broader historical record, showing that Fuego has been in eruption during 46 of the past 127 years, a pattern of recurring escalation from baseline activity into major paroxysms that the current 24-year continuous phase sits within as the latest, longest-running chapter. The named scientists and observers who have documented this volcano across the 20th century, working from INSIVUMEH's predecessor agencies through to the present monitoring network, describe a consistent structural pattern, long stretches of manageable, survivable strombolian activity, punctuated periodically by paroxysms whose timing is recognizable only in retrospect, exactly the pattern this report's live data section described when discussing threshold crossing failure at both of tonight's volcanoes. A third parallel belongs to Santiaguito specifically, and it concerns the dome complex's own documented history of escalating pyroclastic activity. INSIVUMEH's news archive for this site records a strong explosion and dome collapse, preceded, according to Guatemala's National Disaster Coordination Agency, CONRED, by 34 small to moderate explosions within the preceding 24 hours, a rate CONRED itself characterized as quite unusually high, suggesting elevated magma or gas supply into the dome. That earlier event produced pyroclastic flows reaching several kilometers in length and prompted preventive evacuations in communities south and southeast of the dome. The pattern, a measurable spike in small to moderate explosion frequency immediately preceding a larger collapse, is precisely the accumulation then threshold sequence this report's live data already described, now confirmed as a repeating, documented feature of this dome complex's behavior across more than a decade of INSIVUMEH's own published reporting. Each of these three parallels, drawn from three separate documented periods spanning more than a century, describes the same underlying structure. Extended seismic or eruptive buildup, recognized by contemporary observers with whatever tools were available at the time, followed by escalation into significantly more dangerous activity. The 1902 sequence is the most extreme case and the clearest match to this week's combination of two simultaneously elevated systems. The 1974 and dome collapse precedents confirm the same basic pattern. Build-up crossing into sudden escalation is a recurring structural feature of this complex, not a one-time anomaly. The pattern in the modern record is clear, but we do not stop at the modern record. There is an older layer, tablets, manuscripts, oral traditions, documented predictions, that logged events matching this signature long before our instruments existed to confirm them. That layer is what comes next. The data is in the record, and the historical sequence is in the record. Now we go to the layer that predates instruments, predates newspapers, and in one case, predates the Spanish arrival in this region entirely. Before the eruption that created the crater Santiaguito now grows inside, the mountain itself already had a name. In the Quiché Mayan language, spoken by the indigenous population of Guatemala's western highlands for centuries before Spanish contact and still spoken by more than 1 million people today, the volcano now known as Santa Maria was called Gagsanul, meaning naked volcano or naked mountain. This name is documented in the historical and linguistic record compiled by scholars including Adrián Recinos and Deliaguetz, whose 1953 published work on Guatemalan indigenous traditions preserves the Cachiquel Mayan legend describing abnormal activity at the mountain under this older name, predating 1902 by an unknown but substantial span of time. Volcanological researchers examining this legend in subsequent decades have noted that some of the described activity may actually refer to the more frequently active neighboring peak, Cerro Quemado, whose own documented eruption in 1818 survives in a detailed contemporary drawing held by the John Carter Brown Library, a genuine, physical, datable historical record rather than an undated oral fragment. We are naming this scholarly caution directly, because this report's standing principle is that the ancient angle must be real and verifiable, never inflated beyond what the documented source actually supports. What the record reliably establishes is this: the Quiché and Cachiquel Maya peoples maintained, for an unknown span of pre-contact and early colonial history, an active naming and oral tradition relationship with the volcanic peaks surrounding them, specific enough to assign individual names and individual character to mountains that European geological science, as late as the final years of the 19th century, was still classifying as long extinct and safe. That gap between indigenous naming tradition treating these mountains as active presences worth tracking and naming individually, and European scientific classification treating the same mountains as dormant curiosities, is itself the first precise parallel this report wants to draw. The 1902 eruption surprised the formal scientific establishment of its era specifically because that establishment had not maintained the kind of close, continuous, generationally transmitted observational relationship with this landscape that the indigenous naming tradition implies. The naming itself, Gagsanul, naked volcano, describes a mountain stripped bare, exposed, a description that maps with unsettling precision onto what the 1902 eruption actually did to Santa Maria's summit, stripping away the symmetrical, forested cone the geologist Gustav Eisen had described as beautiful and perfect only years before the explosion tore open its southwest flank entirely. There is a broader Mesoamerican textual framework worth bringing in alongside this naming tradition: the Popol Vuh, the Quiché Maya creation narrative, preserved in written form following Spanish contact, but drawing on a substantially older oral tradition. Scholarly translations by Dennis Tedlock and Alan Christensen Both render the Popol Vuh's central cosmological structure as a sequence of creation cycles in which the world is made, destroyed, and remade multiple times, with fire functioning throughout not merely as a destructive force, but as a generative one, the agent that clears a previous creation to make room for the next. Christensen's translation specifically identifies a passage concerning the birth of fire within this creation cycle, describing fire emerging from a mountain in a structured sequence, a gathering of energy, a release, a manifestation that fills a defined space, and a return to a state of preparation for the next release. Mesoamerican scholars studying pre-Columbian volcanic culture have noted that this description, while not using technical volcanic vocabulary, maps onto observed volcanic phenomena in a manner consistent with a people who lived among and had direct generational experience observing actively erupting volcanic systems, including the historically active Santiaguito and the more recently active Fuego itself. We are not claiming the Popol Vuh contains a specific verifiable prophecy naming Fuego or Santa Maria by date in a way that predicts this week's activity. We are noting, as a matter of documented textual and scholarly record, that the Quiché Maya cosmological framework for understanding fire mountains describes a structured, cyclical pattern: accumulation, release, partial completion, renewed accumulation, repeating indefinitely, with the number 4 recurring throughout Mesoamerican cosmological systems as the count of completion and renewal. That structural description, a system that periodically gathers, releases, and immediately begins gathering again rather than discharging once and falling permanently silent, is the same pattern this report's live data and historical sections have already described in modern, instrumented terms. Fuego's 24 years of continuous gather and release activity, and Santiaguito's 104 years of dome growth punctuated by repeating collapse. The Quiché framework did not have plate tectonics. It had centuries of direct, generationally transmitted observation of fire mountains behaving in exactly this rhythm, and it built that observed rhythm directly into its account of how the world itself is made and remade. A second tradition, drawn from the broader Mesoamerican cultural sphere bordering the Quiché Maya region, gives us a more explicit, named Theology of Volcanic Fire. In Aztec cosmology, documented most extensively in the Florentine Codex, the 16th century compilation produced by the Franciscan friar Bernardino de Sahagún, working directly with Nahua indigenous informants, the god Xiuhtecuhtli, the turquoise lord, is named explicitly as the Lord of Volcanoes, the deity of fire, day, and heat, and the personification of the force dwelling beneath the earth's surface. Sahagún's informants, men who had grown up within the living Aztec religious tradition before its disruption by Spanish conquest, described Xiuhtecuhtli as dwelling inside a turquoise enclosure at the center of the earth, a cosmic axis linking subterranean volcanic forces directly to the surface world and the heavens above, a description scholars have read as depicting a deity whose domain spans precisely the physical pathway magma actually travels, from deep storage beneath the crust, upward through a structured channel, to eruption at the surface. Xiuhtecuhtli's worship was not confined to abstract theology. The Florentine Codex documents that sacred fires were kept perpetually burning in his honor at temples throughout the Aztec world, including the Templo Mayor in Tenochtitlan, and that his influence permeated the entire volcanic belt running through Mesoamerica, from Popocatépetl near the Aztec capital to the more distant ranges within the broader cultural and trade sphere the Aztec world maintained contact with. Eruptions across this volcanic belt were interpreted, according to the Codex, as manifestations of Xiuhtecuhtli's wrath or his renewal, a duality worth sitting with. The same deity governing both destruction and the regenerative aftermath that follows it, a theological structure that maps onto the same gather, release, regather pattern already drawn from the Quiché Popol Vuh, now confirmed independently in a related but textually distinct Mesoamerican tradition. The most specific and best documented Xiuhtecuhtli ritual, the New Fire Ceremony, also called the Binding of the Years, deserves direct attention because of its precise structure. Held once every 52 years, at the completion of a full cycle of the Aztec calendar, the ceremony required every fire across the empire, from temple braziers to household hearths, to be symbolically extinguished simultaneously. Priests then gathered atop a specific mountain near the capital and waited for a precise astronomical alignment, the constellation the Aztecs called the Xiuhtecuhtli, known to modern astronomy as the Pleiades, to reach a defined position before kindling an entirely new fire, carried back out to relight every extinguished hearth across the empire. The codex's own framing, as recorded by Sahagun's informants, describes empire-wide apocalyptic dread accompanying the extinguishing of the old fire, a fear that the new fire might fail to kindle and the world itself might end in darkness, followed by communal relief once the new flame was successfully struck and distributed. We want to name, plainly, what makes this ceremonial structure relevant to tonight's report rather than simply an interesting piece of unrelated mythology. The 52-year cycle the new fire ceremony marks is not a volcanic measurement, it is a calendrical one, tracking the convergence of the Aztec solar and ritual calendars rather than any specific volcano's eruptive rhythm. We are not claiming otherwise. What the ceremony demonstrates, in precise and well-documented form, is a cosmological worldview built entirely around the idea that fire, the same elemental force, Xiuhtecuhtli, governs both in volcanic eruption and in the smallest household hearth, must periodically be extinguished completely and then renewed from nothing, on a fixed, anticipated cycle, with the interval between extinguishing and renewal treated by the entire civilization as a moment of genuine, justified collective anxiety about whether the renewal will actually occur. That is, in theological language, almost precisely the structural anxiety this report's live data section described in technical volcanological terms, a system that has been releasing pressure in smaller increments for a long period, Fuego's 24 years, Santiaguito's 104, where the open scientific question is whether that incremental release reliably prevents a larger future failure, or whether the incremental pattern is itself simply the visible portion of a much longer accumulation still building toward a renewal or a failure that has not yet arrived. Xiuhtecuhtli was also closely associated, according to multiple sources Sahagun and subsequent scholars have documented, with Xiuhtecuhtli, the old god, an alternate or overlapping aspect of the same fire deity, typically depicted as aged and weathered in contrast to Xiuhtecuhtli's youthful, vigorous standard depiction. Scholars studying this dual aspect have read it as a theological acknowledgement that fire, and by extension the volcanic forces fire represented, possessed both a youthful, immediately erupting character and an old, patient, long-accumulating character simultaneously, two faces of the same underlying force. That dual aspect framework maps onto the dual character this report's live data section identified between Fuego's youthful, frequent, readily observable Strombolian bursts and Santiaguito's older, slower, far more patient accumulation inside a crater that has been quietly growing for over a century. Two different rhythms, the same underlying force, exactly as the Aztec theological tradition described it, independently, centuries before either volcano produced the data this report opened with tonight. There is a number this report planted in its opening minutes inside the live data on Fuego's instrumental record, and we said we would reach it before the report closed. That number is 24, the count of consecutive years Fuego has now been erupting without interruption, and we answer it now by way of a third ancient tradition, neither Mesoamerican nor indigenous to this hemisphere, connected to tonight's report through a category, not a coincidence. The precise classification volcanologists use for the largest, most violent style of explosive eruption a volcano can produce. Santa Maria's 1902 eruption is classified in the modern volcanological literature as a Plinian eruption. That classification is not arbitrary. It is named directly after a specific historical eyewitness, Pliny the Younger, a Roman statesman who, as a teenager in the year 79 of the Common Era, watched the eruption of Mount Vesuvius from across the Bay of Naples, and later recorded what he saw in two letters addressed to the historian Tacitus, written roughly 30 years after the event from direct personal memory. Those letters survive as the first extant written description of a volcanic eruption in human history, and the eruptive style they describe, a towering, sustained column of ash and gas rising tens of kilometers into the stratosphere, followed by pyroclastic flows that overwhelmed the surrounding towns, became, nearly 2,000 years later, the scientific template against which volcanologists measure every comparably explosive eruption since, including, by name, the very eruption that created the crater Santiaguito grows inside today. Pliny's account describes the eruption cloud rising in a shape he compared first to a tree trunk, then spreading at its top into a form resembling a pine tree, an image modern volcanologists recognize immediately as a description of an umbrella cloud, the mushroom-shaped spreading top of a sustained Plinian eruption column, described by a direct eyewitness 17 centuries before satellite imagery existed to confirm the physical process generating that exact cloud shape. Pliny also recorded that the sea appeared to be sucked backward before the worst of the eruption, attributing it to the shaking of the land, a description modern seismology recognizes as physically accurate for the kind of water displacement that can accompany strong ground shaking near an erupting coastal volcano. A teenager, writing from memory decades later, with no scientific vocabulary for what he had witnessed, recorded two separate physical phenomena with enough precision that both have been independently confirmed by modern understanding of eruptions of this exact style. The deeper relevance to tonight's report lies in what happened to Pliny's own uncle, Pliny the Elder, an avid naturalist who, on seeing the initial eruption cloud, decided the event needed direct investigation and sailed toward the volcano rather than away from it, eventually dying near the shore, by his nephew's account, suffocated by the dense volcanic fumes the slower-moving but ultimately lethal phase of the eruption produced. Pliny the Elder's death is the first documented case in Western recorded history of a trained, knowledgeable observer correctly identifying a major volcanic event as significant enough to warrant direct investigation, and dying as a result of underestimating how lethal that same event would become within hours. The historical parallel to tonight's report is not that either Guatemalan volcano is approaching Vesuvius-scale catastrophe. This report's live data section was explicit that no agency has issued any such warning. The parallel is structural. Pliny the Elder correctly read the initial signal as significant and still underestimated the speed and scale of what followed. A documented historical instance of the same threshold crossing dynamic this report's briefing section described, where both Fuego's 2018 disaster and Santiaguito's dome collapses, in INSIVUMEH's own retrospective analysis, began as activity consistent with established patterns before escalating, within hours, into something categorically more severe. The Vesuvian eruption Pliny documented was followed, in subsequent centuries, by a long, well-documented sequence of further eruptions at the same volcano, recorded across the years 203, 472, 512, 685, 787, 968, 991, 999, and 1007 of the Common Era, according to the historical catalog Encyclopaedia Britannica and subsequent volcanological sources have compiled. The explosions of 512 were severe enough that the Gothic ruler Theodoric released the people living on Vesuvius's slopes from their tax obligations entirely, a civil administrative response to volcanic hazard recorded in formal historical documents nearly 15 centuries before INSIVUMEH's modern alert-level framework existed to perform the equivalent function. That sequence, repeated eruption after repeated eruption across more than 9 centuries following the single most famous eruption in Western history, demonstrates, in an entirely separate volcanic system on an entirely separate continent, the same fundamental pattern this report has now traced through Fuego's 24 years, Santiaguito's 104, the Quiche gather and release cosmology, and the Aztec 52-year fire cycle, volcanic systems capable of producing catastrophic, history-defining eruptions do not, by producing one such eruption, exhaust their capacity to produce another. They settle into a rhythm of smaller releases, sometimes for decades, sometimes for centuries, and the documented record across independent civilizations watching independent volcanoes reaches the same conclusion every time. The smaller rhythm is not evidence, the larger capacity is gone, It is evidence the system is still active. That is the answer to the number this report planted earlier. 24 years of continuous eruption at Fuego is not, by the standard the documented historical and ancient record sets across Vesuvius, Santa Maria, and the broader Mesoamerican theological tradition this report has now walked through, an unusually long or unusually concerning duration on its own. It is, instead, exactly the kind of duration the historical pattern would predict for a volcano that produced its last true paroxysm in 2018 and has been incrementally rebuilding pressure since, in the same structural rhythm Pliny's Vesuvius, Santa Maria's 9-month 1902 precursor sequence, and the Quiche and Aztec cosmological frameworks all independently describe. A fourth tradition, separate from the Mediterranean and Mesoamerican material already covered, comes from the Vedic textual corpus of ancient India, specifically the Rig Veda and the Atharva Veda, among the oldest continuously preserved religious texts in human history. Composed in early Sanskrit and transmitted by scholarly consensus through oral recitation for centuries before being committed to written form. Both texts center extensively on Agni, the Vedic god of fire, addressed in hymns that describe him not as a distant, abstract force, but as a fire dwelling specifically within the earth itself, within rock and within water, alongside his more familiar domain as the fire of the hearth and the ritual sacrifice. The Atharva Veda's hymn to the earth states this directly, that there is a divine fire in the earth and in the plants, that the waters carry the fire, and that the same fire dwells within the rocks, a description of fire as an immanent, geologically embedded force, rather than a phenomenon confined to visible flame. This Vedic framing of fire as a force resident within rock and stone, rather than something that merely burns on the earth's surface, is a distinct theological move worth sitting with, because it describes, independently and without any access to plate tectonics or magma chemistry, the same underlying physical reality this report's briefing section explained in technical terms. The fire driving both Fuego's strombolian bursts and Santiaguito's dome growth originates not at the surface, but deep within the rock itself, generated by the subduction of the Cocos plate and the melting of mantle material at depth, rising through the crust to reach the vents. This report's live data has tracked all night. The Rigveda's hymns to Agni describe him filling both worlds, heaven and earth, with his radiance, streaming with smoke into the sky. An image that, read alongside Pliny's nearly contemporaneous description of Vesuvius's ash column rising into the stratosphere, describes the same physical phenomenon, recorded independently by two unconnected ancient civilizations on opposite sides of the world, each without any awareness the other tradition existed. The American Institute of Vedic Studies, in its scholarly treatment of this material, also notes a documented parallel within indigenous North American tradition, the Cherokee recognition, as recorded by the Cherokee leader S.D. Young Wolf, of four great fires, the fire of the sun, the fire of the earth, the cooking fire, and the life fire within human beings, a four-part fire cosmology that echoes, in entirely separate cultural and geographic context, the same recurring Mesoamerican emphasis on the number 4 as the structural count of completion this report has already drawn from the Popol Vuh's creation cycles. We are naming this cross-cultural recurrence directly because civilizations with no contact with one another, separately arriving at a cosmology in which fire is understood as a force resident within the earth itself, capable of building, releasing, and rebuilding in structured cycles, is the clearest evidence this report can offer that the ancient record's description of volcanic behavior is not coincidental folklore. It is the consistent, independently arrived at conclusion of multiple separate civilizations who spent centuries directly observing fire mountains behave, recorded in their own languages, preserved through their own distinct methods of transmission. 4 traditions, on 3 continents, 4 languages, independently encoding the same observed structure: accumulation, release, renewed accumulation, into their cosmological frameworks, because that structure is what a long-lived volcanic system actually does, and attentive human beings, watching closely enough and long enough, have always been able to see it, even without a single instrument to confirm what their own eyes had already shown them. The data is in the record, the interpretation belongs to you. As this report is filed, 2 volcanoes in Guatemala remain in confirmed, agency-tracked eruption. Tonight we walked through the full instrumental record for both. Fuego, 16 kilometers from Antigua, producing 6 to 12 explosions per hour with a paroxysmal event on June 12th that lit the highlands before sunrise, now 24 years into the longest continuous eruptive phase in its documented history. And Santiaguito, 23 kilometers west, the dome complex still growing inside the crater Santa Maria's 1,902 explosion carved open, producing confirmed pyroclastic flows this week as the Caliente dome continues the same incremental collapse and rebuild cycle it has maintained for 104 years. We named the agencies behind every figure in this report. INSIVUMEH, Guatemala's national seismological and volcanological authority, whose multi-instrument network of seismic stations, gas-flux monitors, thermal cameras, and field observation posts produced every bulletin this report quoted. The Washington Volcanic Ash Advisory Center, whose satellite and modeling pipeline cross-verified INSIVUMEH's ground observations independently throughout, and the Smithsonian Institution's Global Volcanism Program, whose international catalog situated this week's Guatemalan activity within the broader context of global background volcanism. It is worth restating, plainly, the specific numbers this report has carried throughout, because they are the figures worth remembering after tonight's report ends. Fuego, 6 to 12 explosions per hour as baseline, a paroxysm on June 12th that reached 4.5 kilometers above the vent, nearly 4.5 times the routine daily maximum, and 24 consecutive years of continuous eruption, the longest such phase in the volcano's documented 500-year history. Santiaguito, confirmed pyroclastic flows on multiple dates across the past 2 weeks, an ash column reaching 3,200 meters above sea level, and 104 years of continuous dome growth inside a crater opened by an eruption that ejected, by the most conservative published estimate, 4.3 cubic kilometers of material, and by the upper estimate, more than 10 times that figure. Those are the numbers the agencies are watching tonight, the same numbers their counterparts will still be watching tomorrow morning when the next bulletin window opens. Those numbers are worth carrying away from this report. We then walked back through the documented historical record, the 9 months of escalating seismicity that preceded the 1,902 Santa Maria eruption, correctly read by the people of this region as significant, even without instrumentation, to confirm why. The volcanologist William Rose's own peer-reviewed characterization of that period as extremely abnormal seismicity, published 7 decades after the fact. Fuego's 1,974 paroxysm and its place within the volcano's broader pattern of recurring escalation from baseline activity, and Santiaguito's own documented history of explosion frequency spikes immediately preceding larger dome collapses, confirmed across more than a decade of INSIVUMEH's published reporting. And then we went further back than any agency record reaches, into 4 independent ancient traditions, the Quiche Maya naming of Santa Maria as Gagsanul, naked volcano, and the Popol Vuh's cyclical creation cosmology built around fire that gathers, releases, and gathers again, the Aztec theology of Xiuhtecuhtli, Lord of Volcanoes, and the 52-year new fire ceremony built around the structured anxiety of extinguishing fire completely before its anticipated renewal. The Roman eyewitness testimony of Pliny the Younger, whose letters describing the 79 CE eruption of Vesuvius gave volcanology the very classification, Plinian, that describe Santa Maria's own 1902 explosion, and whose uncle's death stands as the first documented case of a knowledgeable observer correctly reading a volcanic signal as significant while still underestimating its speed, and the Vedic hymns of the Rigveda and Atharva Veda describing fire as a force dwelling within the rock itself, independently arriving at the same physical truth modern subduction zone science now measures directly. As this report is filed tonight, the instruments at both Guatemalan volcanoes are still running. INSIVUMEH's seismic network continues recording explosion signals at Fuego in real time. The gas flux monitors continue sampling sulfur dioxide output, The observation posts at Panimaché, Sangre de Cristo, and the slopes of Acatenango continue their visual watch through tonight's darkness, the same darkness under which the volcano's incandescent material remains visible from a safe distance. At Santiaguito, the seismic station designation STG-3 continues listening for the specific signature of dome collapse inside a crater that, on many nights this week, has remained obscured by cloud cover, exactly as it has been obscured on most nights across the past 104 years. None of these instruments sleep, and none of the people whose job it is to read them have stopped reading them simply because this report is now drawing to a close. The file on both volcanoes remains open in the most literal sense available. Agencies actively monitoring, in real time, as this report airs. There are specific things worth watching in the coming days and weeks, and we want to name them plainly rather than leaving vague unease in their place. Watch INSIVUMEH's special bulletins for Fuego. If the agency's explosion rate reporting returns toward the routine 6 to 12 per hour baseline without a further paroxysmal event, that is the historically expected outcome, consistent with the vast majority of Fuego's intermediate-scale pulses across its 24-year eruptive phase. Watch for any escalation in sulfur dioxide flux specifically, since INSIVUMEH treats sustained gas output, not merely explosion count, as the more reliable indicator of continued magma supply from depth. Watch the Washington VAX ash advisories for any sustained increase in plume height beyond the 4 to 5 kilometer range this report has documented all week, since a genuine escalation toward 2018 scale activity would be expected to manifest there first. At Santiaguito, watch specifically for INSIVUMEH's special bulletin language. The agency's choice to issue special reports rather than routine updates has already, this week, told us more than any single explosion count, and a continuation of that elevated reporting cadence beyond the next several days would itself be a meaningful signal. Watch, too, for any GPS or ground deformation data INSIVUMEH releases regarding either edifice's flanks, since sustained inflation at either volcano, rather than the explosion-by-explosion activity this report has tracked all night, is the kind of signal that would most directly indicate a larger event building beneath the surface, rather than simply continuing the established incremental rhythm. And watch the Smithsonian's weekly volcanic activity reports, which will continue to log both volcanoes alongside the global background rate of 20 to 50 actively erupting systems worldwide, the context against which everything in tonight's report has to be properly measured. We also want to be honest, one final time, about the limits of what any of us, agencies included, can actually know right now. The historical and ancient material this report has walked through does not predict an eruption. It does not give either volcano a deadline. What it gives us, and what we believe is worth the time we have spent on it tonight, is a documented, multi-civilizational pattern recorded independently across 3 continents and more than 2,000 years of written and oral testimony, describing exactly the kind of accumulation and threshold behavior that modern instruments are measuring in these 2 specific mountains right now. The Quiche who named Gagzanul, the Aztec priests who extinguished every fire in their empire once every 52 years, not knowing if the new flame would catch. The Roman teenager who watched his uncle sail toward a mountain that killed him. The Vedic poets who placed fire inside the rock itself, rather than merely above it. None of them had access to a seismometer. All of them, watching closely enough and long enough, arrived at the same structural understanding. The agencies monitoring Fuego and Santiaguito are operating from tonight. That a long quiet does not mean an ended capacity, and that a steady, survivable rhythm of small releases is not the same thing as a system that has stopped accumulating. It is worth sitting briefly with how strange that convergence actually is once it is set out plainly. A National Geological Survey in 21st century Guatemala reading sulfur dioxide flux off a gas measurement instrument bolted to the side of a mountain has arrived at functionally the same operating assumption as a Quiche storyteller working entirely from observed pattern and oral memory, that this category of mountain does not finish what it starts in a single event, and that the right posture toward it is sustained attention rather than either panic or dismissal. Neither the agency nor the storyteller needed the other's framework to reach that conclusion. Both reached it because the underlying physical behavior of these volcanoes has not changed in the time separating them, only the vocabulary available to describe it. That is, in the end, the entire premise this channel operates on, that the instruments and the old record are not competing explanations of the same event, but two independent lines of evidence arrived at by entirely different methods that happen to agree. Before we close, a word about what this channel does and why we think it is worth a nightly watch. Tonight's report was not a 5-minute news clip and not a 30-second alarm. It was a full, sourced, agency-verified accounting of two real volcanic systems, cross-referenced against the documented historical record of their own past behavior and against 4 independent ancient civilizations who watched mountains exactly like these, for centuries before any instrument existed to confirm what they were seeing. That is the layer beneath the headline the daily news cycle does not have the runtime to deliver. A morning segment can report that Fuego is erupting. It cannot explain what INSIVUMEH's own institutional history owes to 1902, what the Quiche called this mountain before Spanish contact, or why a Roman teenager's 2,000-year-old letters still define the scientific vocabulary used to classify Santa Maria's worst eruption. That deeper layer is what we file on in this same depth every single night, whatever the agencies have logged that day, wherever on earth it happened, because we believe the full record, instrumented and ancient together, is worth more than a headline. If tonight's report was useful, the most direct way to support it is simple, and it costs nothing but a few seconds. Leave a comment telling us what you would like us to track next, since topic requests directly shape what we cover going forward. Share tonight's report with one person who would find this kind of depth useful rather than exhausting, and subscribe, so the next filing reaches your feed the moment it goes up, because we are filing again tomorrow night on whatever the instruments and the agencies have given us by then. We read every comment. This channel exists because people kept asking for exactly this kind of report, and it continues because people keep showing up for it. We continue to monitor. We will report again at last light on whatever the instruments, the agencies, and the long human record still have left to tell us.